Here is the topic, exercise number 5.4. Problems on exponential function differentiation and logarithmic function differentiation. An easy topic. Exercise number 5.4. Differentiate the following with respect to x. Differentiate the following with respect to x. First one, e raised to x upon sin x. E raised to x upon sin x. Second one, sin of tan inverse e raised to minus x. Okay. Third one, log of cos e raised to x. Log of cos e raised to x. Fourth one, e raised to x plus e raised to x square plus 1 e raised to x raised to 5. Okay. And next one is log of log x. Fifth one, log of log x. And sixth one, cos of log x plus e raised to x. Log of cos x plus e raised to x. And these two are common for you. Okay. Seventh one, it is this seventh one, root of e raised to root x. Eighth and ninth is homework for you. Cos x upon log x, simple. Cos x upon log x. And ninth one is e raised to cos inverse x. 10th one is a raised to x upon e raised to x. A raised to x upon e raised to x. 11th one, homework is e raised to 2x into log of 3x. Okay. First one, differentiate with respect to x means you have to take d by dx. Differentiate with respect to x means you have to take d by dx. Okay, d by dx of e raised to x upon sin x. It is in quotient form. E raised to x numerator is also having x, denominator is also having x. Therefore, this is the quotient form. It is in the quotient form u upon v. What is the quotient formula? First of all, apply the quotient formula of differentiation. Here it is whole divided by the denominator the whole square. In the denominator is sin x, numerator is e raised to x. It is sin x into denominator into differentiation of numerator minus numerator into differentiation of denominator. Is it not? U by v. D by dx of u by v is in the denominator v the whole square. In the numerator v into d by dx of u minus u into d by dx of v. Here comes minus now plus. Here it is now differentiate. You have to differentiate e raised to x, you have to differentiate sin x. That's all. It is sin x into e raised to x differentiation is e raised to x minus e raised to x sin x differentiation is cos x. After writing the quotient formula, we have to differentiate those functions in front of d by dx. In front of d by dx, what are the functions are there? Those functions are to be differentiated. Whole divided by it is sin x the whole square, means sin square x. Is it not? And e raised to x is common in the numerator. It is sin x minus cos x upon sin square x. That's okay. The second one is sin of tan inverse e raised to minus x. Second one, d by dx of sin of tan inverse e raised to minus x. Okay, it is in component function, it is not in the product formula. Sin x is not there. Therefore, sin of tan inverse e raised to minus x. Function of function. Three functions are there. One is tan inverse, the sin, another one is tan inverse, third one is e raised to minus x. Okay, first of all, on sin differentiation. Sin f of x differentiation. With the d by dx of sin f of x. Sin f of x is equals to cos f of x into d by dx of f of x. Okay, that's equals to cos of tan inverse e raised to minus x. Here f of x is tan inverse e raised to minus x. Here f of x is what? Tan inverse of e raised to minus x. Sin of f of x. The term inside in front of sin itself is f of x. Therefore it is cos f of x into d by dx of tan inverse into d by dx of f of x. What is the f of x here? F of x is tan inverse e raised to minus x. Sin f of x, d by dx of sin f of x is cos f of x into d by dx of f of x. F of x is tan inverse e raised to minus x. Okay. Now tan inverse e raised to minus x, it is in tan inverse f of x form. With the tan inverse f of x differentiation, tan inverse f of x d by dx of tan inverse f of x is, tan inverse x differentiation is 1 upon 1 plus x square. Tan inverse f of x differentiation 1 upon 1 plus f of x the whole square. Tan inverse x differentiation 1 upon 1 plus x square. But tan inverse f of x differentiation 1 upon 1 plus f of x the whole square into d by dx of f of x. Therefore it is cos of tan inverse e raised to minus x into 1 upon 1 plus e raised to minus x the whole square into d by dx of e raised to minus x. Okay. Now e raised to minus x differentiation, still it is in the e raised to f of x form. Okay, there are three composite function differentiation. Is it not? One is sin of f of x, another one is tan inverse f of x, and third one is e raised to f of x, because e raised to x, d by dx of e raised to x is e raised to x, but in place of x, what is that? Minus x is there. Therefore it is in the form of e raised to f of x. I told in place of x, one minus is additional, then also it should be taken as f of x. Okay. D by dx of e raised to f of x is equals to e raised to x differentiation is e raised to x only. E raised to f of x is e raised to f of x into d by dx of f of x. What is the f of x here? For this one, f of x is minus 1. No need of taking all these things. Okay, these are all not necessary for examination. These are all explanations. In this case, f of x is e raised to minus x. In this case, f of x is equals to minus 6. For sin f of x is tan inverse e raised to minus 6, sin f of x. For tan inverse f of x is e raised to minus 6. For e raised to f of x is minus 6. Carefully observe the equation. Okay, you should have the patience, you should have the keen observation, then only you can, what it is, improvement. So I have observed majority of you are not ready to view the whole video. You are not ready to view the whole video, you are demanding. So in the beginning you are demanding, we are not following through what it is, that Zoom package. Actually clever students are now claiming that Zoom package is suitable than this one. Because both listening as well as learning happens at a time. Here you have to, again, what it is, you have to, at a given time, both learning and listening happens at a time. But here it is not like that. We are, at any time you can open and you can view the video. But you are not willing to even open and view the video. There in Zoom package there is a compulsion. At that time you have to enter and you have to learn. You have to sit for the whole class. But here no compulsion. You are not at all learning anything. You are not at all viewing the video also. I am observing that every view time is below 5 minutes. Even though 30 minutes video is there, every view time is below 30 minutes. With this attitude, what you can achieve in your life? What you can achieve in your life? You are reluctant to do anything. Only after the enjoyment time pass. With WhatsApp and other games, you are ready to spend 3, 4, 5 hours continuously. Without working, without toiling hard. Would you like to enjoy your life? How it is possible? Nowadays, time being is possible because parents are feeding. Once parents are not in a position to feed, then you have to survive on your own. With this background, with these qualities of what it is, working nature, how you will survive? Nonsense fellows. Demanding, audio is not clear, video is not clear. It is crucial period of education. Simply for namesake, bluffing others. It is cos of tan inverse e raised to minus x. Tan inverse e raised to minus x into 1 upon 1 plus e raised to minus 2x. Why minus 2x? A raised to m whole raised to n is m into n. E raised to minus x whole raised to 2 is 2 into minus x. A raised to m whole raised to n. A means any base. It may be e or it may be a. A raised to m whole raised to n is a raised to m, and therefore minus 2 into x. E raised to m whole raised to n is e raised to mn minus x into 2 minus 2x into d by dx of e raised to minus x. That's equals to e raised to minus x. E raised to minus x into d by dx of minus x. This type of simple composite function should be in a position to write it directly. E raised to minus x differentiation, e raised to minus x into d by dx of minus x. Minus x is minus 1. Therefore, it is minus 1 e raised to minus x. Simply don't waste 2, 3, 4 steps for such simple differentiations. Okay, it is cos of tan inverse e raised to minus x upon 1 plus e raised to minus 2x into e raised to minus x is the differentiation of minus x is minus 1. Finally, the answer is, let us write like this, minus 1 means minus it is. Minus 1 into e raised to minus x is minus e raised to minus x. I will take it in the beginning. E raised to minus x cos of tan inverse e raised to minus x upon 1 plus e raised to minus 2x. 1, 2, 3 worst students are there. Okay. So they are misleading others. So I know which is the fellow responsible for that stoppage of what it is, Zoom class. Yes, he stimulated all his circles because he wants the classroom class, for not for learning sake, for his enjoyment sake. Otherwise, by this time, entire syllabus could have completed. I could have completed the entire syllabus through Zoom package, and revision by this video is possible. If the continuation is there, now we are revising it through video. I told revision, at the time I told that revision we are doing by the classroom. This is also classroom class. This is better than classroom class. If you are ready to listen, you are ready to watch, then it is better than classroom class because you can revise it again and again. Nothing is unexplained. Everything is we are explaining. Suppose you are not following anything, so revise it and try to understand it. So one video is really, if I am releasing the video today, so 20 days is necessary to watch it, not for full video, 2-3 minutes. 20 days is necessary for all people. Okay? Because there is no responsibility for you, neither by the part of learning nor by the part of payment. 10, 12 times I told, pay the fees, but you are not ready to pay the fees. Both the side you are not having any responsibility, learning side also, payment side also. And third one, d by dx of log of cos e raised to x, d by dx of log of cos of e raised to x. This is a log f of x differentiation, d by dx of log f of x. Log f of x is 1 upon f of x into d by dx of f of x. So one ordinary student can understand this particular expression, log f of x. Log f of x is cos e raised to x. Therefore, what is the answer? 1 upon f of x. F of x means compare these two equations. Log 1. in front of log cos e raised to x is there. That is f of x. Therefore f of x is cos e raised to x in front of log is there. That is f of x. Therefore f of x is cos of e raised to x. Therefore 1 upon f of x, 1 upon cos e raised to x into d by dx of f of x. F of x is cos e raised to x. Now it is simply not cos x. Cos e raised to x means it is in cos f of x differentiation. What is the cos f of x differentiation? D by dx of f of x is cos e raised to x. And d by dx of cos f of x, cos f of x is minus sin f of x. Minus sin f of x into d by dx of f of x. That's equals to 1 upon cos of e raised to x into cos differentiation minus sin e raised to x into d by dx of f of x. What is the f of x here? E raised to x. You get cos f of x. Cos e raised to x. Therefore, for cos f of x section, f of x is e raised to x. It is into d by dx of e raised to x. Cos f of x differentiation. It is not simply cos x. Cos of e raised to x. Therefore, cos f of x differentiation minus sin f of x into d by dx of f of x. Now, e raised to x is a simple function. D by dx of e raised to x is e raised to x only. Therefore, it is equals to minus sin e raised to x upon cos e raised to x. Sin upon cos, sin theta upon cos theta minus tan e raised to x into e raised to x differentiation e raised to x. Understood how I have written tan here? Sin upon cos, angle is same now, e raised to x, e raised to x. Here is bracket, no bracket. So sometimes for composite function, sin 3x, no need of bracket. By putting bracket, nothing wrong in it. Okay? Sin of 3x if bracket is written, then you can understand clearly it is sin f of x form. So for simple composite function, bracket will not be used. Sin of e raised to x, sin of 3x, sin x by 2. Okay? Bracket is not necessary, huh? But you have to understand it is composite function sin 3x, sin of f of x. It is neatly finally e raised to x minus e raised to x tan of e raised to x. Tan e raised to x or tan of e raised to x, one is the same. Okay? And now fourth one, d by dx of d by dx of e raised to x plus e raised to x square plus e raised to x cube plus e raised to x raised to 4 plus e raised to x raised to 5. Take d by dx to each and every term. Okay, that's equals to d by dx of e raised to x plus d by dx of e raised to x square plus d by dx of e raised to x cube plus d by dx of e raised to x raised to 4 plus d by dx of e raised to x raised to 5. E raised to x differentiation, e raised to x. Simple. But e raised to x square, the d by dx of e raised to x square is e raised to f of x differentiation, e raised to f of x. Okay? X is not there, x square is there, means e raised to f of x differentiation. All are in form of e raised to f of x because x is not there. X square, x cube, x raised to 4, x raised to 5. Therefore, all are to be taken as e raised to f of x. E raised to f of x differentiation. E raised parallel to simple differentiation, composite will be there. E raised to x differentiation, d by dx of e raised to x is e raised to x. E raised to f of x differentiation, e raised to f of x into d by dx of f of x. That is e raised to f of x into d by dx of f of x. What I am writing here. Okay. Therefore, now e raised to x square directly I will write without writing d by dx of x square. It is 2x plus why it is d by dx of. Therefore, 1 I will write here d by dx of e raised to x square f of x is x square e raised to x square into d by dx of x square f of x. E raised to f of x differentiation, e raised to f of x into d by dx of f of x. That is e raised to x square into differentiation of x square is 2x, like others. So you have to write it directly. Otherwise in CET, etc. So If you are not writing what it is, differentiation directly, you are not practicing directly, then later on it will be each and every minute things you are writing step by step, not necessary in theory examination also. Okay. But in theory examination you can manage the time even by writing each and everything, because everything you can explain with the explanation also, not necessary actually, and elaborately you can write, but it is not necessary in theory examination also. But such type of, if you are addicted to such type of what it is solving, then it will cost heavily in CET. Okay, so try to narrate the things in short. E raised to x cube differentiation, e raised to x cube into d by dx of x cube differentiation, 3x squared, x raised to n differentiation, n into x raised to n minus 1, x cube differentiation, 3 into x raised to 3 minus 1, e raised to x raised to 4 into differentiation of x raised to 4 is 4x cube, 4 into x raised to 4 minus 1, plus e raised to x raised to 5, e raised to f of x differentiation, e raised to f of x into differentiation of x raised to 5x raised to 4. You can expect 2 marks or 1 marks question on these what it is, first 9 problems, okay, 9 or 10 problems. That's equals to neatly right side, e raised to x plus 2x e raised to x square plus 3x square e raised to x cube plus 4x cube e raised to x raised to 4 plus 5x raised to 4 e raised to x raised to 5. And fifth one, d by dx of log x. Log x. It is in the form of log f of x. F of x itself is log x. Log f of x differentiation already is given. Log f of x differentiation 1 upon f of x into d by dx of f of x. That's equals to 1 upon log x into d by dx of log x. 1 upon log x into differentiation of log x is 1 by x. That's equals to 1 by x log x. Number of times this question is asked, log x. Okay. Sixth one, d by dx of log of, again log f of x differentiation. Here it is log x. Log x is simple. Log x differentiation 1 by x. Log of log x is log x simple. Log simply x is not there. Log of some equation x. It is log x only. Therefore f of x is log x. Sixth one, d by dx of log of cos x plus e raised to x. Log f of x differentiation again. What is the log f of x differentiation? Here it is given now. Log f of x differentiation 1 upon f of x into d by dx of f of x. Therefore 1 upon, here f of x is what? Cos x plus e raised to x. And here f of x is what? Log x itself for this problem. It is equals to 1 upon cos x plus e raised to x into d by dx of cos x plus e raised to x. Now it is 1 upon cos x plus e raised to x into cos x differentiation minus sin x plus e raised to x differentiation e raised to x. So in need, you write finally e raised to x minus sin x, and write like that, because instead of minus a plus b, which is better? B minus a is better. Minus a plus b, 1 into the plus b means plus b, minus a upon cos x plus e raised to x. Next one, seventh one, root of e raised to root x. Seventh one, root of e raised to root x. D by dx of square root of e raised to root x. Root f of x. Overall, it's in the outside root f of x is there, no? Therefore, it is d by dx of root f of x. What is the root f of x? It is 1 upon root f of x into d by dx of f of x. It is not root f of x differentiation. At the outset, you are getting root. Therefore, it is in the form of d by dx of root f of x. Square root of inside, simply x is not there, some equation of x is there, therefore it is root f of x. E raised to root x. That's equals to 1 upon, it is 2 root, 1 upon 2 root f of x formula, 1 upon 2 root e raised to root x, because d by dx of root x is 1 by 2 root x. d by dx of root f of x is 1 upon 2 root f of x into d by dx of f of x into d by dx of e raised to root x. Now e raised to root x in which form? E raised to f of x form. Okay, e raised to f of x differentiation 1 upon, e raised to f of x differentiation, e raised to f of x into d by dx of f of x. Therefore, it is 1 upon 2 root e raised to root x into e raised to root x into d by dx of root x. Because e raised to x is not there, e raised to some equation in x, root x is there. Therefore, e raised to f of x differentiation, d by dx of e raised to f of x. E raised to f of x into d by dx of f of x. f of x is root x. Is it not? So 1 upon 2 root of e raised to root x, this part is over, we have to differentiate e raised to root x in front of d by dx. What equation is that? That equation is to be differentiated in the next step. Is it not? So that's why now these two parts as it is, e raised to root x as it is, 2 root of e raised to root x as it is. Now I have to differentiate root x in differentiation process step by step. In front of d by dx, what is that? That part is to be differentiated. And left of that one, left of d by dx, whatever is written, should be maintained as it is. Into d by dx of root x differentiation 1 upon root x. Okay. It is also root a, it is also root b. Root a into root b is root ab. Therefore, in need I can write e raised to root x upon 2 root of x into e raised to root x. Okay. Why the x is taken under one root? Because root a into root b, that's equals to root of ab. This is also root, root means square. This is also square root of a into square root of b, square root of a into square root of b, square root of ab. So x is written first because square root of ab is same as root of ba, ab is same as ba. Therefore, it is e raised to root x into x under one root, root a into root b, root of a into b is e raised to root square root of e raised to root x into x. But x is written in the beginning. I told you always while writing a term, then the technique. First sign plus or minus, then the constants like the numerical constant 2, 3, 4 or even alphabetical constant a, b, c, d, then variables x, y, etc., then functions e raised to x, sin x, etc. Next one, 8th one, d by dx of, it is 8th one is homework for you. Okay. So 8th, 9th and 10th is homework for you. Okay. It is in the form of f, u upon v. Simple function it is u upon v. Okay. And u upon v. Both are simple functions, not composite. These orally we can solve it. D by dx of cos x upon log x is whole divided by log x whole square in the numerator. Log x into differentiation of cos x is minus sin x. Therefore minus log x sin x minus cos x into differentiation of log x is 1 by x. Therefore, minus cos x by upon x. The answer is, it is actually log x into minus sin x log x minus cos x upon x whole divided by log x whole square. D by dx of e raised to cos inverse x is in the form of e raised to f of x. E raised to f of x differentiation is e raised to f of x into d by dx of f of x. Means d by dx of e raised to cos inverse x is e raised to cos inverse x into d by dx of cos inverse x. Cos inverse x differentiation next step, e raised to cos inverse x into cos inverse x differentiation of simple minus 1 upon root of 1 minus x square. The answer is minus e raised to cos inverse x upon root of 1 minus x square. A raised to x upon e raised to x, composite function. Sorry, u upon v formula. It is u upon v. Both are, but a raised to x differentiation given a raised to x log a. E raised to x differentiation, e raised to x. Apply the u upon v formula because both are variable. Every variable in the numerator and denominator variables are there. Therefore, quotient formula at the same time e raised to x differentiation is a raised to x log a and e raised to x differentiation is e raised to x. E raised to 2x into log 3x. It is in the product form. But both are composite functions. U into v. What is the d by dx of u into v? U into d by dx of v plus v into d by dx of v. E log 3x differentiation 1 upon 3x into d by dx of 3x. E raised to 2x differentiation e raised to 2x into d by dx of 2x. Apply the product formula. differentiate